Hi, good morning. Today we are going to talk about trapezoids. So the last shape we are talking about in this chapter are quadrilaterals. We know have four sides, and we've so far talked about parallelograms, rhombus, square, rectangle. We've also talked about the kite. Today we're going to talk about a trapezoid, and this is going to be a quadrilateral with exactly one pair of parallel sides. Okay. Now, those two parallel sides are known as the base or the bases. And then we also are going to talk about an isosceles trapezoid. This is when we have a quadrilateral with exactly one pair of sides that are parallel, and the legs are congruent but not parallel. So if you look here at this picture, you can see these two legs. The legs connect the bases, and they are the same size. They are congruent, but they are not parallel to each other. Okay? So those are our two vocab words. Pause it if you need more time to write them down. We know that the base of a trapezoid theorem tells us if a trapezoid has one pair of congruent base angles, then we know the trapezoid is isosceles, meaning these two sides are the same. Now, likewise, sorry, it's giving me problems. There. If a quadrilateral is an isosceles trapezoid, then we also know then that it says that each pair of base angles will be congruent. So D and C are the same, A and B are the same. Now, one thing I want to point out, anytime we have parallel lines cut by a transversal, so if I have, actually let me do a better line than that. If I have parallel lines cut by a transversal, you can see right here, these two look very similar to like AD here. Those are called interior angles. They're consecutive interior or same side interior. They will be supplementary. They will add up to 180. Okay? Now, the final thing we know about trapezoids is that the diagonals of an isosceles trapezoid are going to be congruent. Okay, so DB and AC would be congruent there. So, take a look here, and the first thing we can do right from the start is we can fill in the angle 3 has to be 135. We should know that right away. That is 135 degrees. Right away we know that. Okay, the next thing we know, we said 180 take away 135. That will tell us what angle 1 is. So 45 degrees. And not only is angle 1 45 degrees, because it's isosceles, these base angles are the same, angle 2 is also 45 degrees. Now, letter B here, it's the same exact situation. We know that number 3 is 47 degrees. Meanwhile, angle 1 has to be whatever 180 minus that is. And angle 2 is also 133 degrees. Example 4 here, it says find the value of x in the isosceles trapezoid, then find the given measurement. If we look here, KM and JL, they are diagonals. Since it's an isosceles trapezoid, it tells us, we know that these two sides are the same. We also then know the diagonals will be congruent. So I can just do 2x plus 10 equals 5x minus 11. Add 11. (21) equals 3x. We'll divide by 3. X equals 7. Now we need to find JL, so we can plug that in. If you didn't like that one, you could also plug it into KM because they are the same. 5 times 7 is 35. 35 minus 11 leaves us with 24 as our answer. This last one, I don't know if we even really need to solve. We know if it's isosceles, the base angles are congruent. So I could do 4x minus 25 equals 2x plus 55. However, I'm going to save us some time. If you solve, you will get x equals 40. You'll plug it in, you'll get 135. Now, the one other thing we need to talk about with a trapezoid is our mid-segment theorem. And we know that this is the mid-segment, xy, because x is the midpoint of BA. We can see these two sides are the same in length. Y is the midpoint of CD. These two sides are the same in length. So xy is the mid-segment. And the mid-segment of a trapezoid is parallel to each base, and its length is 1/2 of the sum of the lengths of the bases. So if we add the top and the bottom and divide by 2, we get that mid-segment. Now, if we look here, if this is 20, we know the mid-segment's 14. We know this is a difference of 6. So from 14, we'd also have to have a difference of 6, which would be 8. If you want to double check it, add 8 plus 20, that's 28. Divided by 2 leaves us with 14. Now, this next one is a little bit tougher, because here we know if we add the two segments together, two bases together, and then divide by 2, we will get whatever the mid-segment is. Okay, so we've got it set up. Now if we're dividing, the opposite is multiplying. So let's multiply by 2, multiply by 2. Then combine like terms. Subtract. Divide. And we get x equals 9. Now it asks us what BC is. We need to plug that in. 9 times 3 is 27. Plus 11. 38. Now the difference here from 38 to 28 is 10, so that's minus 10. If we'd subtract 10 again, we'd have 18, which makes sense. 2 times 9 is 18. Final example, RS. On this one, we know the top and the bottom, if we add them together and divide by 2, we'll get this mid-segment. So once again, we can multiply by 2. Okay, at this point, combine like terms. Add the 2. Divide by 4, and you'll get x equals 8. So that is all for today. There is a Delta Math. Remember, test on Wednesday. If you need help or if you are feeling behind, please reach out. Let me know. Hope you have a great day.